January 18, multiple choice for geometry on the Regents, questions 11 through 15. Rectangle ABCD prime is the image of rectangle ABCD after a dilation centered at point A. By a scale factor of 2/3, which statement is correct? Now, 2/3 is a shrink. It will make ABCD smaller as it becomes ABCD prime. So which is correct? Rectangle ABCD has a perimeter that is 2/3 the perimeter of the preimage. So if the sides are proportional, which they are because they're multiplied by a scale factor of 2/3, the perimeter will also maintain that same ratio. So this, I know, is the correct answer, but we're going to read the rest and talk about why they're not. Okay, circle this. Rectangle ABCD prime is a perimeter that is 3/2. Well, 3/2 is 1.5. Why would the perimeter of a shrunken figure be bigger than the perimeter of the original? That doesn't even make sense. Rectangle ABCD prime has an area that is 2/3 the area of rectangle ABCD. Well, this might be tempting to pick, but it's not really true. Area is squarea. So if you wanted to find out what the ratio of the areas was, you would actually take 2/3 and you would square it, and so it would be 4/9. That's a little trick for you. We didn't get to that in our lessons either. Oh, there's the work. You would take 2/3 squared. That's 4/9. That would be the area. And of course the area isn't going to get bigger. The equation of a circle is x squared. This is number 12. The equation of a circle is x squared plus y squared minus 6x plus 2y equals 6. What are the coordinates of the center and the length of the radius of the circle? So I'm going to, again, just like in the last Regents, show you how to do this, and hopefully you guys will pick it up. The notes are posted in the Google Classroom. So I'm going to change the order here. I need x squared minus 6x plus y squared plus 2y equals 6. And I'm going to deal with this first, and then I'm going to deal with this second. We're going to be doing something called completing the square. Okay, so to complete the square for the first variable, we take 6 divided by 2 and square it. That's 3 squared, which is 9. So I'm going to add 9 to both sides. I'm going to add the 9 here. Okay. There we go. And then to complete the square here, I'm going to take 2 and divide by 2 and square it. That's 1 squared, so that's 1. So I'm going to add 1 to both sides. Don't forget about this 9 for the other side here. So we have y squared plus 2y plus 1 equals, here we go, 6 plus 9 plus 1. So now we're going to take this quadratic and we're going to factor it, and then we'll take this quadratic expression and we'll factor it as well. So 2 parentheses, and I'm going to have matching. Matching, that's what that plus means, negatives. And the square root of 9 is 3. Plus, don't drop the plus in between. Sorry about the blurriness here. And then we have matching positives. Square root of 1 is 1. 6 plus 9 plus 1 is 16. So when we simplify this here, we have x minus 3 squared plus y plus 1 squared equals 16. And since this is a circle equation, remember how it looks like a squared plus b squared equals c squared, where the c squared is really the r squared, so we know that the radius is 4. Radius is 4, so we can cross off 3 and 4. 3 and 4 are gone. And then we just have to remember, are these going to be the same sign or the opposite sign? And the answer is opposite sign. So the center is positive 3, negative 1. The negative 3 translates it back to the origin, and the positive 1 translates it back to the origin. So the center of our circle is at 3, negative 1. And so we are picking choice 2. In the diagram of triangle ABC below, DE is parallel to AB. So you should remember from right before we left off, took off school, if they're parallel, it divides the sides proportionally and it makes similar triangles. So you can look at this a number of ways. We're not dealing with these sides, so I'm going to look at this as a big triangle and a small triangle. So the big triangle side here is really 24. What is the length of DE? So if I write big over small and pick a big side that I know, the big side that I know is 24. And a corresponding small side is 15. That equals the other big side that I know over x. So if you organize this as big over small or small over big, I don't care. Now we're going to cross multiply. Divide by 24, x equals 25. So read the question again. We labeled everything correctly. Find the length of DE. We're going 3, 25. The line whose equation is 3x minus 5y equals 4 is dilated by a scale factor of 5/3 centered at the origin. Which statement is correct? Okay, so whether I need to or not, my first instinct is to put this in slope-intercept form. So 3x minus 5y equals 4. I'm going to subtract 3x. And divide by negative 5. Everything separate. Okay, so there's my equation in slope-intercept form. Now, what you know when you dilate a line is that the slope stays the same because dilated lines remain parallel unless you do something to them. Dilated lines remain parallel, so I need the slope to stay the same. So let's read these choices. The image of the line has the same slope as the pre-image but a different y-intercept. The image of the line has the same y-intercept as the pre-image but a different slope, so that's got to go. The image of the line has the same slope and the same y-intercept as the pre-image. The image of the line has a different slope and a different y-intercept from the pre-image. So now I have to decide, will my intercept be the same or will my intercept be different? And, well, what is this 5/3 scale factor for anyway? Well, that's for multiplying times the intercept. So if I take negative 4/5 and I multiply it by 5/3, Sorry, hold on. I get -4/3, which is not the same intercept. So I'm choosing the image of the line is the same slope as the pre-image but a different y-intercept. I already knew that this intercept was going to be different because I'm multiplying a number times a number, and they're not 0 or 1. So, all right, so last question in this section, number 15. Which transformation would not carry a square onto itself? Let's draw a square, and we'll have a visual to look at. Let's put its diagonals in there too. Okay, here we go. Not carry, would not carry a square onto itself. Reflection over one of its diagonals. Well, if I fold that sucker in half on its diagonal, it's going to, if I drew it perfectly, it would map right onto itself. So I'm going to cross off number 1. A 90-degree rotation clockwise around its center. So if I rotate this around the center, 90 degrees, doesn't matter if it's clockwise or counterclockwise, because the sides are congruent and all these parts rotationally are congruent. It has symmetry in so many different ways. I know that that will map onto itself. A 180-degree rotation about one of its vertices. Now this is important. It's not 180 degrees around the center. It's 180 degrees around one of the vertices. So if I rotate this whole square 180 degrees, do you know where it ends up? Down here. That's where it ends up. That's 180 degrees. That doesn't map onto itself. So I'm going to circle 3 and check 4. A reflection over the perpendicular bisector of one side. Okay, so this is wordy, but if you pick one side and the perpendicular bisector finds the midpoint, if I fold it on that line, it will fold perfectly in half onto itself.